Hey there, I'm Quentin Ruff, and this is my presentation on a unified theory of locomotion, which is from Game AI Pro 3, Section 3, Movement and Pathfinding, and it is Chapter 18, and this is for MI 431, Project 4 Research Phase. And I am Quentin Ruff. So let's start out with this chapter's overview and motivations. So what is a unified movement system? Why do we want to use it? So, first, moving AI characters around is really hard, especially doing it in complex ways and in ways that look good to players and look smart to players. The combination of different movement systems leads to code that's really hard to debug and prone to breaking. So, we need to figure out a way to combine our movement systems in a way that makes sense, right? So here's how we look at the problem. So first we got to break down character movement into a series of steps. So first the character has a goal location, and then once they figure that out, they have to figure out the best way to move through the world to the destination. So this is our A star part. So breaking up the world into a larger series of sub goals, and then figuring out how they get from here to here to here to here, so that way they can get to their final goal. And then the character has to determine if there are any dynamic obstacles, if any, that exist, and that would prevent them from getting to their next sub goal. And then they have to get around those, but also they need to make sure they don't just run in the opposite direction, right? They have to be keeping their general kind of path towards that sub goal or towards the target goal. And then finally, the character has to do all of this stuff while trying to keep themselves as possible to their ideal velocity. So whatever velocity their upper AI has decided, right? And so now that we know that, that's great. But how do we actually, use that to with our movement systems? And we use it with the unified theory approach. And so a unified theory of locomotion can be used to describe and communicate between different movement systems. And each system is described in terms of how they influence key movement values, position, velocity, and acceleration. And so we describe these as being either restrictors or directors, right? So a position director, a position restrictor, a velocity director, a velocity restrictor, acceleration director, or acceleration restrictor. And when we use this common language between everything, it helps simplify the integration of all these different systems, and it clarifies the individual roles of each movement systems components, and it just improves the robustness and the ease of debugging or extending the AI behavior. So it's a lot easier to go in and figure out what's broken, or if you want to add in a new system, it's not so hard because you know how it'll fit into everything you have so far in this high level way, right? So here are the fundamental components of locomotion. You heard me say them a second ago, but we're going to break them down in some more detail. So first up are the movement attributes. And so the unified locomotion theory, it breaks down character movement into three main physical attributes. So first up is position, so that's where the character is located in the world right now. Next up is the velocity, so that's how fast they're going, or the direction they are actually traveling in. And then lastly is the acceleration, so how their velocity is changing over time. And so we use these three movement attributes with our restrictors and directors. And so each restrictor will narrow down the range of permissible values by removing options. So it's basically saying you can't go here, you can't do this, you can't speed up in this way, you can't aim in this direction, that kind of thing. So for example, a nav mesh will act as a positional restrictor since it defines where a character can or cannot go. And then we also have directors, which are a little bit more complicated, and they provide a target or ideal value for a movement attribute to go to. So for example, path planning and steering behaviors are seen as positional or velocity directors. They output ideal directions or velocities that guide a character toward the goal. And something to be aware of before we continue looking at how we actually use this is cascading value dependencies, because all of this stuff, when you use it together, is going to have interconnected effects. So influences on one movement attribute can indirectly affect the higher level ones. For example, by restricting where a character can go, you indirectly limit the set of velocities that character might choose, since moving into forbidden positions isn't allowed. And so it's really important to understand the order of like operations that your movement system works in, because things might be not allowing other systems to do their job if they're in the wrong order. So it's just something to really be aware of. And so now that we understand the unified theory of locomotion, let's think about how we actually put it into use. So once we understand, like, okay, this is a positional restrictor, this is a velocity director, how do we actually use all of that information together with our character? So it's pretty tricky, you know. That's why we had to make this, or that's why somebody had to make this entire system. But it's not too bad, and the person who did is pretty clever, so we're lucky there. So first off, with restrictors, they're combined really simply. It's just additively, or it's called taking the union, right? So you just, if you can't go here and this other thing says you can't go in this other place, then you can't go in both places. It's pretty simple, because it doesn't really matter how much you can't go to a place, because you just can't go to it. So those are just additively combined, and it creates a set of like non-allowed values. And directors are a little bit trickier, right? Because they say where each system, which uses completely different logic, wants to go. And those can be in completely different directions. And if you just straight average them out, you'll get really weird, unpredictable, and just bad behavior. And we want our characters to feel smart, right? Not be walking in a strange, like, weird line because I'm standing here and the door's standing here and it wants to go this way and this way, so it ends up just walking like that. Like, that's the type of thing that we want to avoid. So we break things up into two levels. We first have a high level and then a low level. And on the high level, we first figure out which systems should be prioritized in that current moment, right? So if a character is in a really crowded condition, then they're probably going to want to prioritize their collision avoidance over their formation keeping. And then once we understand that, we go down to our low level and we combine our different directors with either like weighted summation or priority ordering, just in a way that makes sure that the most important systems are weighted much heavier than the other ones. And so this ensures that while all the systems do have an effect to some degree, it is only the ones that are really important at that time that really influence the character's motion and influence those like important things like the general direction they're heading in or the general speed they're heading in, right? So let's take a look at this whole thing in conclusion. And I think it's pretty cool. It's pretty dang cool. I have not really seen a solution like this before for like doing complicated movement, and I think this really breaks it up into a way that makes sense and is not too difficult to implement. Like, it's just a good AI structure, and it makes stuff easier to debug and look through, or would do that if I did it right, because it's just I'm doing a slideshow about it. But I would use this in the future if I had more complicated AI movement that I had to do. But yeah, this is a super cool chapter from Game AI Pro. Thank you again. And if you want to look at it yourself, it is again on their website. It is book 3, section 3. And the unified theory of locomotion. I've been Quentin Ruff. Thank you very much for watching.